Okay, g'day, my name is Coulter. My first DevOps Day conference was here in Philly a year ago, and I was so impressed at the content and the interactions that I saw that I knew I wanted to come back and speak this year. And thank you for your, thank you to the organisers who have allowed me to speak this time, and also thank you for the next 30 minutes of your life. I'm going to talk about Aiops. Who's using Aiops today? All right, one person. That sounds about right. We're functioning on DevOps. We're doing good things with DevOps. It's been a great process for us, but it helped us get through agile computing. It helped us keep the performance deliverables of our companies and enterprises that we needed. But what we need to do is, we're now under a lot of stress. We've introduced a lot of tools and complexity from taking on the challenge of DevOps. And, I remember from the sessions here last year and some of the sessions on the list today that, we're all under a lot of stress and pressure. I'm now under the pressure to try and share Aiops with you within 30 minutes, and would normally take about 90. I'll try and be good. So I want to ask you a question. I'm going to ask some questions on the way through, so make sure your arms are limited, put your arms up at the right points. This is me. I'm Coulter. I'm an immigrant and a global citizen. I've lived in 3 countries. I've managed teams in 11 countries, and so far I've visited 35 countries out of about 110 that exist. I like exploring the world. My life has given me that opportunity. I've been on all sides of IT, so I have run data centers, I've been an operator and fed checks into machines. I have been a developer, coding mainly in assembler. I've run development teams on the product side of the industry, and I've been an industry analyst at a company called 451 Research for about 5 years, where I ran the data science organisation. Out of all of that, the thing that most impacts me, I'm now a New Yorker. You'll pick it up a little bit in my attitude, if not the accent. And the thing I love about New York, though, is I have a little outdoor space and growing vegetables out there. Getting vegetables and things that I can eat to grow in New York is a passion. So don't ask me about it during a break, because I will bend your ears. I want you to look at these 4 statements and think, which of these 4 quotes best match you? I'm not going to ask you to put up your hands. I apologise to the camera person, I'm a walker, sorry. I'm going to be all over your screen. All right. Which of these 4 things best match your current environment, the applications you're responsible for, the enterprise you're running? Do you just react to things and then move on after if a performance or an outage happens? Are you proactive that at least at the end, when you've solved the problem, you sort of then hold a post-mortem and try and work out something so it may not happen again? Are you predictive that you're actually seeing it before the customer does? That you're seeing the performance and slowdowns going on in your environment before somebody phones you up and tells you about it? And then the 4th one here is about being preemptive, where you're not necessarily thinking about the environment because you've got the time to focus on getting the code right before it even goes in. So I asked you to think of where you were today. And we asked enterprises, AppDynamics is part of Cisco, our parent company Cisco, ran research across thousands of enterprises at the end of last year. And what they identified was where people were today. And you can see that most people today self-identify as being proactive. They don't just sort of walk away from something once they've fixed it, they then address it. But what they see, what was interesting is that in 2 years' time, the plurality is seeing themselves as predictive and preemptive. And if you think of the workload you have right now, and how you're managing your DevOps, if you've got DevOps in your environment, how you're managing that environment, or if you're an SRE, site reliability engineer, how you're managing your environments, you're going to need help to get there. All of the environment that we have and the application environment we run in has become more complex, and we need to augment ourselves with technology as we have tried to do in the past. So this is a quick presentation in 4 chapters, right? I'm going to talk a little bit about one of the issues that I have with the DevOps, and then talk about machine learning and what that really is. Who's run TensorFlow or some sort of a trained machine learning model? Okay, so not bad, about 10 people out of the room. I'll go through a quick little sort of explanation of how machine learning actually works. Then I'll talk about what Aiops is and the benefits, why you would want to embrace this in your environment, what you will get from embracing it. And then the next question people normally have is, what do I automate? So I have some criteria there to help you work out what to automate. So let's start with surviving DevOps. This visual, we've seen this graphic a lot in the DevOps environment, right? The DevOps ribbon or the Ouroboros snake eating itself. I have one problem with this. This was a great visualization of what needed to happen to get into this sort of continuous environment, but it didn't really account for time. So when I was a developer for the Commonwealth Bank in Australia, they asked me to write an interest calculation module. It needed to be really fast, really efficient, and so they asked me to code it in assembler. So I wrote that. It took me about 2 months to write that code, right? And it was beautiful, kind of thing, or at least I thought it was. But it tested okay, and it didn't fail, and things like that. And we put it in play, and it was used by lots of different applications. About 2 years later, I moved on in my career, and I left the Commonwealth Bank. And they were still using that module. It hadn't been touched. But a friend of mine stayed there, and they were there for 9 years. And in 9 years before they left, I phoned him up and asked him to look, and they were still using the same module. So something that only took me about 2 months to write, 2 months of plan, code, build, test, release, lasted for 9 years in an environment. And that's why I sort of challenged the DevOps ribbon as saying, these things are important, and if you look at importance, that works. But when you look at the lifespan of things and where effort goes in time and monitoring after the time, then it doesn't reflect that as well. I don't necessarily have a better idea, but I just didn't necessarily like that it ignored monitoring. Didn't ignore it, but it sort of didn't give monitoring sufficient lifespan. So this is a hands up question now, whose application environment is more complex than it was 2 years ago? Right? I should have gone the other way, right? Whose isn't? Because that's overwhelmingly a majority in the room. And you're not imagining it, you're not dreaming it. As we look at the application environments, and we debug I can't go too far away from the little transmitter there. The environment got harder on us, right? We used to run, years ago, we'd run an application on a machine. And then we introduced virtual machines, and we sort of had more complexity in the environment, and then we moved to the cloud, and then we were multi-cloud, and then we started going to microservices, and that environment around us, we introduced Internet of Things, we got mobile devices, all of those things got more complex, and by the way, in the same way, languages got more complex as well, that we introduced new languages. So you're not dreaming, the application environment is at a point where humans can no longer comprehend it. It's just beyond our ability to understand the thousands and thousands of metrics that are coming out of an environment like this. And our traditional methods of managing these environments is also leaving us behind. So the separate control planes that we've used in the past of, the security team looks after this and the networking team looks after that, but as a quick example, they both need to be looking at, firewall logs and things of that nature, because is all of that traffic coming in a successful marketing campaign at last, or is it a denial of service attack? So this existing sort of combination of going, we'll split everything up and we'll focus and be an expert in our silo isn't going to work anymore. So what can we do? How can we augment ourselves? The good news is we've come up with a technology for that, which is machine learning. And as I talk about machine learning, it's important to get the level set right. We've all seen the movies, whether it's iRobot or Terminator or Ex Machina, depending on your generation, where the robot is perfect, and they speak well and they interact with humans and they have social skills, and you can't tell the difference between that and a human being. In the trade, we call that artificial general intelligence. It doesn't exist today. And I would posit, and I'm happy to argue this over a cup of tea later on, it will never exist. What we have today, at least, is that we train robots to do things. This robot was taught to identify a handle, turn the handle, open the door. Right? It wasn't taught what to do if the door was already open. And this proves two things, right? One, it's always funny when robots fall over. I think it's the human experience, right? It's just the nature of us. And then the second one is that in machine learning, in artificial intelligence, if you don't teach something, if you don't give something the data it needs to learn something, then it won't learn it. And even worse, it won't tell you that you haven't taught it. A human can stick up their hand and say, I don't know how to do this, you haven't taught me yet. Machine won't. The machine learning won't. So this is this reality check in machine learning. So let's look at a quick training model for those in the room who are machine learning experts and have run these sorts of things. I apologize, this is an oversimplification. You can hate me later. For everybody else, I'm just trying to establish where machine learning actually does, what it actually does. So I'm going to try, well, I'm not going to run it today because I'm not going to take on the demonstration guides. I'm just going to show you some quick snapshots training a model to predict the selling price of a home in San Francisco. I have a data spreadsheet that is full of previous selling prices of homes in San Francisco. I tried to find a data set for Philadelphia, but I couldn't find one. So sorry about that. So the home, simple linear regression. What you get in Excel, y equals a plus bx, okay? So we start off with some basic terminology in machine learning. This is the phrases I use. In brackets are phrases that other people use for the same thing. So you think of, there are columns of data, I call them features. And the thing we're trying to get to is the objective or target. And then each row of information is an instance, okay? So let me go through this. This is in Jupyter. So obviously I'm working in Python. I'm bringing in Pandas here to do the calculation because Pandas is fine for doing simple linear regression type calculations. It's good for that, and it means I don't have to move to R later or something like that. So importing Pandas in here, and then I read in my file. I read in this CSV file of all of the previous sales. And what I get from that, okay, and then I get to, is it loads into what Pandas calls a data frame, which is kind of like a spreadsheet. Then I want to drop unwanted features because training models takes time and processor time consumption. So the best way to minimize that is to not fill it with data that you know won't help. So you have duplicate data, you've got the same information in two places, lose one of them. So I'm dropping unwanted features here. And I don't know, is this sort of legible down the back, hopefully? Okay, I've got an email address at the end. You can get a copy of the presentation later. We see, and then I'm analyzing, I'm now looking for my X value. What in all of those columns of data most closely correlates to the selling price, which is what I want as my outcome. And as you run through here, you'll see that last sold price is 1, because guess what? That correlates to itself 100% of the time. No surprise. The thing that surprised me, though, was that it wasn't sort of number of bathrooms or, everybody says in real estate it's location, location, and location. It wasn't the GPS coordinates that made the correlator best. It was the finished square footage that actually correlated best in this particular data set. So now I've got my X. I still need the A and B in my linear regression algorithm. So I grab the top correlated values for simplicity. And then I begin to train the model to calculate the A and B. So what I'm doing here is I'm taking my input dest, and hopefully you can see up there, it says test_size equals 0.3. So I'm taking my entire data set and I'm splitting it into 70%, 30%. 30% I'm holding aside for testing later on. Because if I trained it on that 30% and then used it for testing, the algorithms have already seen it, it's redundant. So I split off 70%, I train the model, and then I run that additional 30% of data through it to test it. Good so far. That gives me some coefficients. Sorry, I forgot to point them out, but this gives me some coefficients and intercepts there. So now I sort of have my A and B values. And then just to see how it looks, I wouldn't normally do this in the environment for the sake of this conversation, I ran a quick plot using matplotlib to show the data. Now, the interesting thing is that I tend to be personally swayed by outliers. If you had asked me to hand draw a line here, I probably would have drawn a 45-degree line because I see those couple of outliers up the top there. But the machine learning is smarter than me and faster than me, and it's drawn the line more appropriately based on the cluster of data in the bottom left corner. So the outcome here is to understand that a couple of things about machine learning. It's not magic. It's not, the movies. It's just fast. It is faster and more able to identify clusters of information than we certainly are. By the way, can someone give me like a 5 when I'm 5 minutes left, so that, because otherwise I will talk until this evening. Trust me. So AI/ML is not magic, it's just fast, right? So hopefully that gives you a little grip, a little baseline on machine learning, that what you need is lots of metrics, lots of data, lots of different data, so it gets smarter and smarter. And the main thing is, it's just much faster than you are. As good as you are, it's much faster than you are at identifying patterns in masses of data. And if you haven't worked it out so far in the presentation, I grew up on the other side of the world, and I've lived here for about 20 years now, and I don't know whether data or data is the right way of saying things anymore. So I use both. I apologise. So, okay, but what is Aiops? Well, here's a sort of a definition for you to play with. But essentially, Aiops is an augmentation to what we do. And it does it powerfully in several key areas, and I want to talk about each of those key areas. All right? Oh, hello. Got a distinct lag in here. Okay. Okay, so again, hands up question. Who has set up a performance monitoring tool somewhere in their career and had to manually set thresholds, right? Okay, was that fun? No. Anybody? Fun? No. One of the biggest pains in the butt about setting manual thresholds is the aspect of what is normal. It's always the first question. You roll your application out and the people in operations turn around and go, well, where should I set the thresholds? And you're like, we have never run this code before. I don't know. The good thing is that that's exactly what you can apply machine learning to. Let it run into your environment and let it automatically set thresholds for you. And we do this in two ways. There's two key ways that this needs to happen, right? One is historical. So that, if you get a massive logins at 9 o'clock in the morning on a weekday, that's not a bad thing. I mean, I don't know, it might be maybe you get in at 10 o'clock or whenever people arrive at your office. So you get a massive logins first thing in the morning, that's fine. You get a massive logins at 3 o'clock on a Thursday afternoon, you've had an outage or you've got a denial of service attack. So one of the things is understanding the workload historically over time. And again, the machine learning is very good at doing that sort of clustering and working out what's going on. The second one, the one that I love, is contextual. Of the thousands of metrics that it is analysing, it works out, the cognitive engine works out, which metrics are moving together with each other and which ones are moving in opposition to each other, and looks for those patterns in the real world. So it automatically sets the baselines on this information, and then it is looking to that information running in the live environment. So as a quick example, two metrics, transactions per second. You get more transactions, your network bandwidth usage goes up. Makes sense. You sort of look at it and think, yeah, fair enough. So if they go up and down together, that's fine. All right? But if transactions per second goes up and network bandwidth goes flat, you've got a constraint in your environment. You've got an outage or a slowdown about to happen. And this is where on the observational side, on the real-time side, cognitive engines in machine learning can give you the information before the outage, before the phone call, before the ticket. So contextually correlating metrics is a big one. The next one is automated triage, right? Which is, if you think you've got a cluster of instances running in an environment, and your normal monitor will sort of go, here's all your instances, and maybe it'll even show you, hey, these instances are under stress. Right? But then what are you going to do? Step into each instance to try and work out? Because there's lots of ones that aren't under stress, so what's going on here? Machine learning is very good at discerning patterns, very good at identifying clustering. There are specific algorithms for clustering data. So what machine learning gives you is interpreting that information and looking at what it will simply examine the things that you would do. What's common between these, what's different between these, but much faster than you can do it. Now, we won't necessarily show you a chart like that of just, of clustering the data because that's not giving you insight. It's just giving you visibility of the information. Instead, we'd show somebody needs to show an automated root cause type analysis. And if you look at this across the top, the line across the top here, it's showing you what's the first question with any anomaly? When did this begin? When did this start happening? So we put a timeline up the top there to say this is when it started, and you see it eventually goes green, it gets addressed. In the middle, we're showing you visualizing. This is about sort of visual, the observability of the environment. We're showing you the components that are impacting that. But the key thing here is that clustering thing we present in this way, that we will then show you the top suspected causes that are causing these metrics to behave in this way. All right, time for a quick sip. I always get dry mouth when I speak. So, automated root cause, so we have baselining, so you don't have to manually set thresholds. We've got cluster analysis to help identify and triage problems. We've got root cause analysis to take you to the location where the anomaly is happening. Now, sometimes finding the source of something is easy, sometimes it's not, particularly in slowdowns and performance issues. We will guide you in that way. But there's another aspect of this. So we've sort of been so far I've been talking about going from the application down into the infrastructure, whether it's cloud or mobile or whatever, but going from the application down. The other aspect of this is going from the application up. Because while you have a piece of code, I had a piece of code that did an interest calculation. While you have a piece of code that does one thing, the customer's experience or the user's experience is normally a connection of multiple things in multiple locations. And you need to understand that experience and how your code works with that. And that's going from the application up into the business transaction. All right? So you need to load that data in. This is a strategic point. You need to load that information into your cognitive engine as well so it can learn those lessons. What that does for you, and I'm jumping through this in the interest of time, but if you consider an environment where everything in the technology is okay, it's just below the threshold, so it hasn't gone yellow yet, it's just below, but every single piece in the way, you know that your actual customer experience is going to suck because they're now getting seconds of delay from each piece along the way. And you can see that if you can see the business transaction. You see people abandoning your environment. So having talked about, very briefly, about what AIOps is, generally around now in conversations, people are, okay, but I don't want to have to go and deal with that myself all the time because that will kill me too, even though you've saved time on diagnosis and root cause. And if you're an SRE and you have a problem with the phrase root cause, again, I'm happy to have that argument with you later over a cup of tea somewhere. But at this stage, you're thinking about automation. And from all the work I've done with clients, I've come up with 5 criteria to allow you to prioritize what you're going to automate in your environment. So the first one is frequency. And essentially you use these, you create a spreadsheet, you build a list of everything you think you might want to automate, and then you give it values, and then you sort it by the highest value. So let's start with frequency. Frequency is how often does this happen? If it happens a lot, okay, you give it a higher score. If it's the first time it's ever happened, there's a secondary question. Because it might be the first time it ever happened because it almost happened 12 times in the past. So you also want to have a sort of query language around your information and your machine learning so that you can go back and search, hey, yeah, this just broke the model, but did that happen never in the last 2 years or almost 100 times in the last 2 years? And that's frequency. Both did it almost happen and did it actually happen? And that assesses the score. The second is impact. This comes from that business transaction information I was talking about. So you can see whether this outage has an impact. Did it just annoy the operator and nobody else in the world even realized it was happening? Sorry, operator, it's not that important. But was it annoying the customer and it wasn't an issue for the operations and development environment? Very different situation. So you need to understand the business impact of what you're going to trying to remediate through automation. Third one here is coverage. How much of the remediation can you automate? If there's a step in the process somewhere on the way through where you need to pull out, someone has to physically go and pull something out and plug it back in again, or someone has to phone up their cloud service provider and ask them to change a setting, then automating everything around that won't necessarily help you that much unless they're very complex steps. I'll come back to complex and mundane in a second. So coverage, can you automate the remediation entirely? Next one is probability. The probability of success of your remediation. So you've written the world's best shell script, and it's a thing of beauty like my interest code, and you're very proud of it, but it only works about 3 out of 5 times. And the other 2 times, it's you're not quite sure, but it doesn't quite work. The probability of success is another score of what you should automate. And then the final one is timescale. How long does the remediation take? So in that example of the network bandwidth that I gave earlier, right, you just want to give it more network bandwidth. If that happens at 3 a.m., you don't want a phone call. Just give it more network bandwidth and you can fix it at 9 a.m. to work out what's going wrong. That's an easy automation. But maybe remediation needed a rebuild of the database. Maybe remediation needed a recovery of a server. Maybe remediation meant a failover to a disaster recovery site. Well, you may not want to fully automate those. They're complex, so you may want to automate them, but you might want an operator step in there to go, do you really want to do this? And then say yes, and then you move on. Because it's going to impact the rest of your environment. So those are 5 criteria for you to use when assessing what you should automate. And the reason I give you a criteria is because automation incurs technical debt. When you build an automated remediation today, and then you update an operating system or change an application or use a new language, you may have to change that then. So the good news is you only have 5 minutes of me left. All right? And that's good because we're almost at the end here. So how is AIOps going to, I've talked about the benefits of AIOps, the absence of threshold setting, the root cause analysis that is done for you, the narrowing down from, it could be anything to this team needs to work on it. So there is an immediate relief to the engineering burden from AIOps, which is why I thoroughly recommend investigating it today. Strategically, you must consider a cross-domain strategy. You can't just do it for the application. It's got to be done for the infrastructure. It's got to be done with third-party providers. So as I say, from the application down through the infrastructure, from the application up to the business transaction, out on the front end to mobile devices, Internet of Things devices, and so on, and out the back end through your servers and cloud providers and microservices. And the goal is to automate the complex and mundane. Complex because that's how human error gets into systems, because people make a mistake under the pressure of the moment. Mundane because you know what it's like. You've got this thing, and every 3 days you have to sit and type the same damn commands to make this to fix it and get it working again. And you don't need that in your life. So complex and mundane are the things you want to be looking to automate. Another key factor here is that you want to build your human skills. I wrote a piece, Forbes published a piece that I wrote on this topic sort of thing. I've got a link later on it. That we need to be experts in an area. And you are all experts in some particular silo or in individual area. But in today's world, the complexity of where we live, the complexity of our application environments and how we ship code and then how that code runs is so significant. We need some understanding of the rest of that areas. As we go to software-defined infrastructure, infrastructure is becoming software. So operations teams need to be understanding and learning the software development lifecycle, because that's how they're rolling out things now. Similarly, you're putting definitions as you build products and test them. You're putting definitions with it. You're using Spinnaker or Kubernetes or Chef or Puppet. You're limiting the infrastructure capabilities of the environment. Well, what you push through and ship has to be something that can live in the proper infrastructure. So you need to become aware as an individual, instead of just being sort of an I-shape, I'm a coder in this language or that language, we need to become T-shaped skill sets where we have an understanding of what the database does and how the DBA does things with the database, what the network is doing and how it's configured, and how network administrators see their network environment, and straight across all of the technologies and infrastructure. And the last one here is that, as I said at the top of the presentation, if you think your life is complex, it is. You're not alone. Right? You're all in here in the room for a good reason. And we need to augment ourselves, and there is technology out there that can do that. So to bring this home, there's a couple of links there, kind of thing. There's a lot more writing that I've done. You can go to techwhisperer.nyc.com to see some of the posts I've done there. I work for AppDynamics, kind of thing. We have a booth upstairs. We have giveaways and bouncy balls and things like that. So come and see us. Please, come and give me feedback on the presentation. Was this a valuable use of 30 minutes of your life? And I think we're going to a break next. No, we got other things first. Okay.
I got an announcement first. It's my job.
Sorry, what are we doing?
I'll take over. Don't worry about it.
Yep. Okay. Thank you for your time.